Hello, this is Mr. Reese, and this video is going to go into the area of a trapezoid. Let's go ahead and just start right off with the trapezoid formula, and here it is. Some things here that are of note. For a trapezoid, the bases are considered to be the parallel sides, no matter how this is oriented. So for the sake of the formula, we will always write those two bases as one group. The basic idea kind of stems from that of a parallelogram. You see, a parallelogram would have the formula of the base times the height. And you can argue that we're doing the same thing, but with one difference. There are two different bases. So what you are doing here is you're taking those two bases and you're determining an average for them. The average of two numbers basically is when you just add them up and divide by 2. So if you think of it along those lines, you're averaging the bases and then timesing the height. Just like a parallelogram. You can use the same formula for it too, except for a parallelogram the bases are the same, so it's pointless to average them. You just simply pick one of them. It should also be noted that the height always forms a right angle with the bases. So keep these two ideas in mind, and you'll be able to work any trapezoid problem. Thus, if your trapezoid was oriented sideways, these would be the parallel sides. That would be B1 and B2. And then the height would be the distance between them. Because of that, the idea of height is somewhat misleading. When we think of height, we think of how tall an object is. But in this particular case, what we're really saying is that it's just the space between the two bases. How far apart are they? If you like, you could consider just this thing being rotated. So there's nothing stopping you from taking your paper and rotating it, so that way you can look at it in a more proper manner, where the height definitely is how high it is from top to bottom, and the bases are the top and bottom surfaces. So let's try an example now. Let's say you were to determine the area of this particular trapezoid. The steps for solving for the area of a trapezoid are pretty much the same for the area of any figure. First, start out by writing the formula for the area of a trapezoid. It's a good idea to do this only so that way it'll cut down on your studying. If you write down the formula every time you work a problem like this, you won't have to give as much time to studying on your off time and trying to remember this formula. Recall that the bases are the parallel sides, so that's 15 and 9 that are going to go inside the parentheses. The height is really the distance between them, so we look for the right angle to tell us. That would be 6, and that goes here. And now we can go ahead and solve. You'll want to do the math inside the parentheses first, and then from there multiply then divide, or reduce then multiply the result. Either way gives you the same answer. Okay, now let's do another. Let's say in this particular case we are given the area already, and then you want to solve for an unknown side. Again, as stated before, first thing you want to do is write down your formula, then plug in the given values. You already know what the area is. The area is given as 112, so that's going to go right here. Your two bases, remember, are parallel to one another. That's this side and this side. So those are the two that you will be keying on to go in the parentheses. Now remember that the bases and the height form a right angle. And here's your right angle, which means that you're not going to be using 11. 7 is what's going to go right here. So in this particular case, we don't have a use for 11. And now we can go ahead and solve. To finish this off, what you'll want to do is you'll want to eliminate this denominator here. So what we're going to do is we're going to multiply out this number on both sides. What this does is this allows us to reduce out this 2, giving us just the top here. Don't forget to multiply the 2 over here. So that gives you 224 on the left, and then just this quantity here on the right. From here we can go ahead and distribute the 7, then subtract, and then divide. And that's it. Okay, how about we do another? Let's determine the area of this particular trapezoid. As stated before, we want to begin with our formula, and then we want to plug in our values. You might note that the bases are the parallel sides, which are 8 and 18. So that's going to go here and here. However, for the height, it isn't really known. Remember that the height forms a right angle with the bases. That's this length right here. So we wouldn't be writing in 6. This 30-degree angle here, though, is a clue here as to what to do. You might note that this is a 30, 60, 90 triangle. A 30, 60, 90 triangle has 3 different size lengths, with the smallest side being here. The largest side would be twice as large. And by the way, how do you know this is the smallest side? Because it is opposite the smallest angle, and 30 is the smallest in a 30, 60, 90 triangle. Which means this: if your largest side is always twice as big as your smallest side, that means that if this is 6, then the height would have to be 3. So therefore, when you write your formula for the two bases, for the height you're going to write in not 6, but 3. And then from there, we can go ahead and solve the problem. We work the parentheses first, then times and divide. And that's all there is to it. Okay, let's try one last one here. Let's determine the area of this particular trapezoid, only this time we don't have any of the bases. We just simply have its height. This length, you might recognize, is a midsegment. A midsegment is a segment that connects a midpoint on one side, on one leg, to the midpoint of another leg. In other words, not the midpoints of any of the two bases, just the two legs. The midsegment, by definition, in a trapezoid is equal to the average of the bases. So it would equal to this top plus this bottom divided by 2. That essentially is what the formula, what we have for the formula for the area of a trapezoid. It really is just the average of the bases times the height, which means that that part right there is the length of the midsegment. So we can use this formula instead. So let's go ahead and plug in our values. This part's 10, and this part here is 6. That means your area is 60. And that's all there is to it.